Alright guys, I didn't get the video out this morning. I was trying to do something and not everything goes as planned. I'm trying to make an adapter that will accommodate going into this camera, right? This long bar is going to serve as a stationary articulating arm that'll hold the camera in this general area, right? I'll get it all dialed in, and the idea is that with this I'll be able to use the camera to show you some really cool things on a microscopic scale. So we're talking about things of the microscopic world, and I've got a microscope here, and I can show you Euglena, I can show you copepods, I can show you all kinds of things that are growing through mitosis, which we all know what that means now, in these different containers that I have for the Artemia, right? I'm gonna go outside where there's more light. I'm gonna grab a globe and talk. Actually, I need two hands, excuse me. How's everybody's day going? Good? I have no idea how this looks. Okay. Alright, it's windy today. Alright, so I'm gonna put my glasses on. It's pretty bright out here, but you can see me. We are going to sort of be in both the interdependence unit and stepping 1 foot into the human impact on Earth unit, okay? Remember that next week we're doing the human growth and development, so that's gonna kind of put pause to our impact on Earth unit. But so we're phasing out of interdependence, okay, and moving into what humans do to the Earth. All right, so to kind of get a better picture of this, you have to understand where you are, right? Where you are geographically, right? That's why I grabbed this. When it comes to where you are, right, geographically, what location on Earth you happen to be at, that determines what they call climate. Now, weather and climate are two different things. Weather is systems that move in and make rain or snow or different weather conditions, but climate is where it's a common there's a stasis of what type of conditions there are. So it can be a tropical climate. If you're in a tropical climate, it's got high humidity, a lot of thunderstorm activity when during certain parts of the year when it's really hot. If you're in a dry climate, I don't know if you've ever traveled anywhere, like the West is a good example of dry climate, to California, down into Texas. Okay, there's areas that don't have much in the way of humidity, and if you've lived in Florida your whole life and you go to some place that doesn't have humidity, it's quite a difference. But we're going to talk about Florida because that's where we are. All right, now looking at this, I sure hope this comes out. I'll do my best to hold it. I'm going to put where we are, and so I think I may have told you once before, but the Americas, North and South America, all right, they were named after Amerigo Vespucci. He was a map maker who literally charted this area, and as an honor to him, his name sort of lives on. So Amerigo Vespucci is where we get America from. So in the northern hemisphere we have North America. Southern hemisphere we have South America. Now there's this imaginary line that we call the equator, and it's basically where it just divides the Earth into two parts: northern hemisphere, southern hemisphere. Okay. Now the Earth, like whenever you look at a globe like this, the Earth is kind of tilted. All right, it's got a little tilt to it. It's at a 23.5 degree tilt. They call that an axial tilt, and that actually affects something called precession, which you don't really need to know too much about, but it makes a wobble in the Earth relative to its axis, and it changes by like 1 degree every 72 years. I got that worked out. I'll get into that potentially if I teach you in 8th grade. Anyway, so where you are on the Earth depends on how much exposure to the sun you get. So the way it kind of works out is that the sun's energy tends to get the most amount, they call it insolation, that's the term for solar exposure. The most amount of insolation, okay, is the equator north by 23 degrees, 23.5 degrees technically, and south 23.5 degrees technically. So that's the most amount of solar exposure that you get in this area. Okay, so wherever you are in the world, you know, this is Africa right here, moving over to Asia, wherever you are in the world, that's where you get the most amount of solar exposure. And in fact, this country right here in South America is called Ecuador, and that's where the name equator comes from, passing through Ecuador. So the way that this affects us here in Florida is we are in this tropical climate right here. Now, if you were to go back 10,000 years, Florida was mostly underwater. In fact, the furthest south that you could go if you were 10,000 years ago in the current location of Florida would be pretty much around Orlando. That would be the furthest south that you could possibly get 10,000 years ago. Everything else was underwater. But as sea levels dropped, because in the northern and southern poles, you get this lockup of ice. Okay, so you get ice forming, and it pulls water, fresh water, up into the locked up ice, and it lowers the sea level. It's a lot like when you get in and out of a bathtub or something like that. They call that displacement. When you get in the tub, the water rises. When you get out of the tub, the water lowers. The mass of your body is displacing that volume of water. All right, so as the ice was locked up in the northern and southern poles, okay, the sea levels dropped, and there was a reference to this little spot here in one of the videos that we watched a couple of weeks ago. They call that the Isthmus of Panama. All right, and that is a fairly newer feature, geologically speaking, and it's like a land bridge from North America to South America. It goes into the country of Panama. And when that was underwater, the Pacific and the Atlantic were joined together as one ocean. There was not a Pacific and an Atlantic Ocean. It was just one ocean. All right, Panthalasia. But as the water levels dropped, okay, more land was exposed, and that's a geographic barrier. And what that did is that separated this body of water, the Pacific, and this body of water, the Atlantic. And then there's a term I taught you a while back called allopatric speciation, where species evolve due to geographic isolation. There you go, land bridge. Okay, many species that were one species at one time had separated, diverged because of this particular feature. So the way that I want you to kind of give consideration is that we are more or less where Lake Okeechobee is, due east. All right, that's, you know, general area of where we are in Florida. And we watched the video on the Florida Everglades, right? You got to see how important that ecosystem is, and there's all kinds of occupants in that ecosystem. You know, some are you know, we said abiotic and biotic. All right, the biotic factors are certainly all the different plants that we have out there. We've got these trees, they're called mangroves, and there's 3 different types of mangroves. The red mangrove, probably one of the most important because it has the most salt tolerance. The scientific name is Rhizophora manglae. And then the next mangrove in from that would be the black mangrove, and that's Avicennia germanin. And then the next mangrove, we've got 3, is the white mangrove, and that's Laguncularia rasmosa. Those 3 mangroves are extremely important in the formation of land. I know it's kind of a weird thing to think of, but they are the first large plant structure, tree, that deals with the wave action, okay, with tidal flooding and whatnot. So they collect sediments. The way that their root systems are they have these prop roots, and they collect sediments. And when we learned the rock cycle, sedimentary rock, okay, little small parts, sediments, pieces, so they'll collect sedimentation, that's what the term is, and then more and more builds upon that. Okay, so there's this process, and I'll try to speak in picture, but let's just say we're at a lagoon. All right, we're at a lagoon, and the first tree that you see is the Rhizophora mangler. Okay, and then behind that you've got the black and then the white mangroves. And moving into the water, as the water feature starts to, as it drops down, you start to get these different snails. They're called Batellaria minima. They're these little, they're in, you know, tremendous, copious amounts, like uncountable amounts. They break down detritus and whatnot. And then as you move further into deeper water, you start getting, they said in the video, manatee, or turtle grass rather. It's called Thalassia testudinum. You'll get Thalassia testudinum, you'll get Syringodium filiforme, shoal grass. There's all different types of very important grasses that are in the Everglades area. You get the manatees, which are probably the larger, cooler, charismatic thing that you saw. Big manatees, they're called Sirenians. And I took a class in SeaWorld, and they taught us, I'll teach you, the myth of mermaids. Okay, the actual idea, myth of mermaids comes from the Sirenians, the manatees. And I guess the story is that sailors long ago that were out at sea for extended periods of time, they didn't have a lot of water, a lot of nutrition. They were dehydrated, they were delirious, and I suppose that when they saw these large masses under the water with this fluke, they call it, coming up the tail, the caudal tail coming up out of the water, that it resembled a woman, part woman, part fish. So anyway, that's the origin of mermaids. Thought I'd throw that in there. But you've got a wide variety. Won't go into all the different animals that are there, but the ecosystem, okay, consists of so many different, what they call large megafauna, which is fauna is animals, things that are larger that you can see. You have the macrofauna, which is the larger. You have the microfauna, which is the smaller. They talked about epiphytes. There was a kind of a matting algae that they showed. They said that was a very, very important part of the ecosystem, because the area that dries up, they call that ephemeral, when the water goes from being there to not being there during certain parts of the year. When it dries up, that matting algae collects moisture, and it basically saves a lot of life that wouldn't ordinarily dry up. So that helps to protect those areas. And also there's a fun fact they mention about the alligator being what they call a biological engineer. And that means that they dig these holes, the alligators dig these large holes, and by virtue of them digging these large holes, they become this feature. So as the water levels drop down, as the summer months, or the months where it's really not raining much, and water is evaporating faster than it's coming in, and as that water level drops down, those holes become these like little small pools where some fish and different types of marine life can wade out until it starts to get deeper with water due to influx of water or rain. So the biological engineer part of it from alligators becomes really, it's kind of an unintentional situation. It's an unintentional product that they do. They do that for their own reasons, making these holes, but because of them doing those holes, it actually saves that area. So going back to where we are, I think it's probably good that maybe you know the story. So Ponce de Leon was an explorer. Okay, you probably heard of Christopher Columbus, discovering America. Most everybody has. The way I heard it is that Christopher Columbus initially landed in the Bahamas, and he didn't even know he was in the Bahamas. He thought he was over in Asia. He had no idea really where he was, but he's another story. But Ponce de Leon, he was born in let me think for a second, 1574? Yeah. 1474. Yeah, he was born in 1474, and he was sent over to just do like an exploring, and he discovered the area that we pretty much call St. Augustine right now. And when he got there, he called it La Florida, which means land of flowers in Spanish. And St. Augustine became a fort area called the Castillo de San Marcos, and it's the oldest continually occupied city in the United States. But going back to when Ponce de Leon discovered Florida, he starts working his way down the coast. Maybe I'll show you here. Starts working his way down the coast right about here, and he eventually got to the Keys. But maybe I should toggle back. Early settlers of Florida are Indians. Okay? The people that lived here the longest are different tribes of Indians, and Indians tended to go where things were good, where resources were good, where fishing was good, and farming was good, and things that they could grow or get access to so that they could live was good. So they would move when they had to for certain reasons. But as time went on, a lot of time went on, the sea level started dropping, and more of these little islands started to make themselves out of the water and became accessible to these early natives. So they're called Paleo Indians. So they would basically, as these little islands would slowly start to appear and form, because as the sea level was dropping, the land was exposed, that they would go to these islands, they would see what they could get. A lot of times they would get turtles. Turtles are really slow. I mean, they're not really slow, but they're slow enough to catch, and they have a lot of meat on them, every one you catch. Same thing with manatees. So when Ponce de Leon worked his way down to to what we call Key West, he got there and he saw these big piles, they call them middens, big piles of bones, and they were the carapace, the shell of the turtles that the natives had been slaughtering over a long period of time. Just piles of them, and bones from the manatee, rib bones, things like that. So he saw these big huge bone piles, and again, they're called mittens. And when they called it, they gave it a name, and the name that he gave is Spanish. And if you say Cayos, it means little island, and hueso is bone. When you say it together, Cayoesa, that's little island, bone, little island, that's what that means. But as you say that faster and faster, Cayoesa, Key West, you can kind of see where the word Key West came from. But when he got there, he said, "Oh wow, this is great." He sort of made journal logs about what he found. He went back to the King of Spain. His name was King Ferdinand, and King Ferdinand said, "You can go back and you can colonize this new land, Florida, in the name of King Ferdinand." And so there was like a little debate back then, I believe, with Christopher Columbus's son about who was going to govern the areas and whatnot. But anyway, the story goes is that Ponce de Leon goes back to Florida, and he goes to the southwest Florida. So like we're like the southeast, so like the other coast of Florida, and the Calusa Indian tribes that were there, they resisted. They did not want Spanish rule. They did not want settlement of the Spaniards there, and they resisted with violence. And Ponce de Leon was injured badly, and his men fled, so with Ponce de Leon on the ship, and they went to I think it was Cuba, and he died there. So I tell you that so that you kind of get a framework for what Florida was once. Like I said, it was all once underwater. In fact, I've shown many of you a phalange that I have. It's a bone from a paleo camel that I found in a place called Fort Drum. It's in Orlando, going back to Orlando being high and dry about 10,000 years ago. And camels are not tropical animals. I mean, you'll find them at zoos, but naturally occurring, they're in real dry environments. And that goes back to what you now know about continental drift, about the continents once being connected. You got the North America this part of Florida here was once connected to this part of Africa right over here. And so this was more this way, and this was more this way, once connected to that supercontinent Pangaea. So going back to where I found the, right about here, can you see that? Right about there is where I found the evidence of camels naturally occurring in Florida, which that just doesn't happen. So, but when you go back, now that you know the law of superposition, the further you go down into the ground, the further backwards in time you're going. And I was told that it was 60 feet down that this machine was going with this, it's like what they call a bucket, but it's more like a machinery thing that pulls up a large volume of dirt. That's where that material came from, that I found the phalange of that camel. So with your knowledge now that you have learned in 7th grade with me in science, you now know that the world is an ever-changing place and that things will always continue to change. But where we are right now is in a tropical environment, all right? We have hurricanes, we have thunderstorms, we have rain, we have a lot of sunshine, we have a lot of plants, a lot of lush greenery. Things grow real well here. The weather's usually really nice. But one of the things that humans have done, and it's, for all intents and purposes unintentional, is we've disrupted many ecosystems. Okay, we're going to get into that a little more in detail, and I apologize again for the video being as late as it is or was. All right, so make sure that you get